Hi, today we're going to be going over Interactive Student Edition Realize Reader Lesson 1-1. I know most of you have already done this already, but I want to make sure that we go back through it, check your answers, and make sure that you understand all of the concepts. So we're going to be using Freddie here. He's over here on the side working his computer for me. So the first thing that happened was he got into his email and he found the email for this and clicked on it, and it comes up here. In order to get into this program, all we do is click on open.
Hang on.
Uh-oh.
Just a second.
Now, he has to move to where the website which will take him there. You may or may not have to do that. All right, the next thing that should come up is this little box that's got a green box here. It says Interactive Student Edition. You're going to click on Realize. Now, if you don't click on this right now, it'll take you there in a few seconds. And here is the Interactive Student Edition Realize Reader 1-1. So the next thing that Freddie's going to do, Frederick, we'll just call him Frederick.
Yeah.
He's going to click on this little thing here, and here we go. Now, this is what the front of the book is. What's really important is if you went to click on the lesson vocabulary. If you do not know your vocabulary, you're not going to be able to understand how to work these problems. And I'm having a lot of people email me saying, I don't understand. Well, I don't understand what you don't understand, so if you're not specific, I can't help you. Once you've gone through these, and there's a couple here that are not here that you're going to be seeing, what you'll want to do is make sure that you know what all of these are. Average rate of change, you should have learned in Algebra 1. That's the same as slope. Interval notation, we'll get to that later. Maximum and minimum have to do with a graph. We'll get to those later. Set builder notation is another way of explaining the domain and range of a graph. And zero of a function, and we'll get into that later also. All right, the next thing you're going to do is click on the next. All right, the very first part of this Explore and Reason is just a little thing to get you started, warmed up. What I would like you to do is see if you can go through and figure this out. This isn't the important one, but I do want you to try to work it out and see if you can get the answer. Next, Fred. All right, understanding the domain and the range. First up, domain. Domain is all of the x values. Range is all of the y values in a function. In a function. And this is a v, and that's a v, it's not a u.
So do you feel like a
All right.
chart solved?
You'll get used to my writing eventually. All right, so this is the example. So those of you that have books can go through this example. Those that you do not have books, if you want a book, you can come get one between 8 and 3. But what we're going to do is go ahead and go through this example. The first thing they give us, they want to know what the domain and range of this function is, defined by y equals x squared minus 3. Remember, we want to know all of the numbers all the values for x that can go in here that will make y true, and all of the values for y that make x true. So the first thing you're going to do here is hit solution. Now, this gives you an explanation of what's going on here. So here's the graph of this function. Next. The set of all possible inputs for a relation is called the domain. So those are all of x values. You can square any real number, so any number can be an input for x. So in other words, the domain of this function is going to be negative infinity to positive infinity. Now, this type of notation is called interval notation. All right, also I see here, next, the set of all possible outputs for this relation is called the range. That's the y value. So the range here is going to be -3, all of the values from -3 to infinity. So we write this by putting a bracket here. This bracket means that we include -3. So we put in -3, and then it goes to positive infinity. All of the infinities have open brackets. This is an example of set builder notation. Click on the set builder notation. Set builder notation uses a verbal description or an inequality to describe the numbers. So in this case, x such that x is a real number would be your domain, and y such that y is greater than or equal to -3 would be your range. These two right here are the same as these. Again, this is in interval notation. These are in set builder notation. Interval notation. Okay, again, this shows you what I just put over here to the right. So again, the domain is negative to positive infinity, and the range is -3 to positive infinity. And here all they're doing is comparing the different types of intervals. So this would be your interval notation, these would be your set notations. Okay, next thing you do to go to the next problem or example would be to click on that little 0. Again, here we have a practical application. An air tanker flies over the forest fires and drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of water the air tanker can drop in x seconds? The solution, function, f of x. F of x is also y. Some of you are having difficulties with that. That's another concept that should have been taught last year. So f of x, the function of x or y, is equal to 400x. So the air tanker cannot drop water for a negative number of seconds, so x has to be greater than or equal to 0. So here we go. To solve the problem, we take the tanker can drop water for a maximum of 8,000 over 400 or 20 seconds before running out of water. So x has to be less than or equal to 20. The domain then is written in set builder notation. X such that 0 is less than x, which is less than or equal to 20, or 0, 20, where 0 and 20 are both included. Next, the air tanker cannot drop a negative number of gallons, and its maximum capacity is 8,000 gallons. Therefore, the range is going to be between 0 and 8,000 gallons of water, or 0, 8,000 with the two brackets. So the 0 and the 8,000 would be included in your answer.
You want to click on that or go to the next 0?
All right, now you get to try. Now I'm going to go ahead and do these. I know you should have already done them, but you can go back and review and make sure you have done them correctly. The absolute value of y equals the absolute value of x minus 4. It says, what are the domain and range of each function? Write the domain and range in set builder notation and interval notation. Now, I'm going to tell you that it really helps to have a graph. Every single one of you should have a graphing calculator. If you do not have a graphing calculator and your parents aren't going to buy you one, you need to go check one out at the office. So here I have my graphing calculator. I am going to put the absolute value of x minus 4. And then I'm going to graph it. Uh-oh, that's not it. Huh, that's weird. All right, so when I graph this, the graph of this ends up on the y-axis at 1, 2, 3, 4. So 0, 4. So this is 4. And then it crosses the y-axis at 4. This is an absolute value, so it's going to kind of look like a V. And it's also symmetric, so in other words, if I were to drop a perpendicular line to the x-axis, the distance from here to here is the same as it is from here to here. Now, it wants to know the domain and range of this function. And they want you to write the domain and range in set builder notation and interval notation. So, what you would do this is weird. Oh, here it is. The domain is going to be negative infinity to infinity. In other words, I can put any x value in here and come up with the y value. The range is going to be 0 to positive infinity. So in other words, there are no negative y values, only values that are at 0 or above. Now, this is in interval notation. To put it in set builder notation, I would put the set symbol, x such that x is all real, and the range would be y such that y I'm in the wrong stuff. Is going to be greater than or equal to 0. Now, we have another try it down here. Then the next thing you do is check your answer. So, can you put this in there? Domain, this is the domain and the range will be fine. Oh, just put domain. Okay, colon, open parenthesis, negative. Okay, come down here. Okay, let's see. Try this one. Okay, here it is right here. So you're going to put a negative that, so just click on this.
I did.
Okay, and you got a negative in front of it?
It's underneath your writing up there.
Oh, okay. Okay, let's go ahead and take my writing off. Okay, then you're gonna put a comma. Okay, and then put space. Click on this again. Okay, and then come out of here. Okay, press enter. Okay, then range. I'm only going to have him type in 1/2 of it. You would type in this using your computer. All right, so the first thing to do is open parenthesis, and you're going to put in a 0.
0.
I'm sorry, close parenthesis. It's a bracket. I'm sorry. Looks like this.
Bracket.
Okay,
Okay.
0, comma, space, and then you're going to go and put this right here in again, the infinity. And that's open.
Like that. This is a hidden, this gray means it's just hidden.
Oh,
It's not.
it's supposed to be, can you put a comma down there? No? I meant an open parenthesis like here.
You mean a closed parenthesis, like that.
Yes.
Mhm.
That's not, okay.
I can
All
do
right,
that.
then what's gonna happen is that after you put everything in, you're gonna hit the check answer. Now, this is not gonna grade it for you. It will let you go on. You wanna make sure that you have the right answer. If this is not the right answer, then what you're going to do is put the right answer in your notebook.
Erase that.
Oh.
Thank you.
All right, I'm going to let you do this one by yourself. We're going to go on to the next one. So now you're going to go down here and push next. All right, in the next one they talk about finding the x and y intercepts. The x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. Here it says a car starts a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas, y, left in the tank to the number of miles the cars traveled, x. What are the x and y intercepts of the graph of this equation, and what do they represent about the situation? Okay, then you come down here and push solution. And it tells you that the graph above intersects at the axis of 320, 0. This means that the car can travel 320 miles before it runs out of gas. The graph intersects the y-axis at 0.16. So the y-intercept is 16. This means that the car has 16 gallons of gas when it starts the trip. So in other words, 16 gallons of gas will get you 320 miles before you have to fill up again. All right, go ahead and hit this. Now it says, what are the x and y intercepts of the graph of the y equals the absolute value of -3? Push the solution, please. All right, this tells you that this goes through the process of finding what the x and the y intercepts are. Now, a lot of times when I have problems like this, I will have a 0 here. This would be my y-intercept. This would be my x-intercept. So I can go in here and put an x in here. The y-intercept's at -3. You can actually do that in your head. And then if I put a 0 here, the absolute value of x is going to equal 0 plus 3, because you have to bring this over here. So the absolute value of x is going to be 3. The absolute value of 3 is 3, so the x-intercept will be 3. So again, the y-intercept's at -3. It even tells you this. The x-intercepts are at -3 and 3. Oh, sorry. I forgot. An absolute value goes like this. Therefore, if I draw here, we have a -3 and a +3, so it would be plus or minus 3. Because the absolute value of a number will make, if it's positive or negative, will still be 3. Next. And then the y-intercept, of course, is going to be at -3. All right, it says, what are the x and y intercepts of this? If you have a graphing calculator, I would like you to put that into your graphing calculator and read it. My assistant here is going to put on, go ahead and actually, I can go ahead and tell you that this is going to be the x, okay, this is going to be plus or minus 2, so you're going to put -2, +2. Okay, you don't have to put the positive there, but that's the y-intercept.
That equals y.
No, not equals. Just put y-intercepts. So you put colon or something and then put y-intercepts. Actually, y-intercepts, and that's at -2 and 2. And then hold it, that's the x-intercept, sorry. And then the y-intercept is at where did it go? Oh, I'm on the wrong page, sorry. The y-intercept's at 4. Okay, then when you come down here and check your answer, again, if you get the wrong answer, now what this did, it put it in points. So they put it in points. So what you would do is you would go back here. So you're going to go ahead and erase that part. So in other words, you would write it as -2, 0, and 2, 0. That's the point on the graph. The y-intercept's at 0, 4. Yes, Fred?
It will not let you go back while you have the solution.
Oh, that's okay. So what you're going to do in your notebook, you are going to write in the x-intercepts are at, go ahead and put it in point form. This is point or coordinate form. Now that's the whole idea of this, so that you get how the computer wants you to answer. So the next time you get a question like this, you know that you're supposed to answer in point or coordinate form. All right? Okay, let's go ahead and go on to the next problem. We don't want to use blue anymore. It's not coming off. All right, the next thing we want to look at is for what intervals is x squared minus 9 positive. So go ahead and hit the solution. All right, the graph is positive when it's above the x-axis. It does not include the intercepts. Does not include the intercepts. So this one right here would go from negative infinity to negative 3. And then this would be 3 to positive infinity. So go ahead and click on here, I think. So here's how they would run it written in what's the name of it? Interval notation. There we go. Interval notation, this is how you would write it. So again, when y is greater than 0 above the x-axis, x is less than negative 3 when x is greater than 3. All right, so this is how you would write it right here. All right, Negative, when is it negative? It's negative when it's below the x-axis. So f of x or y is less than 0 below the x-axis between the intercepts, x-intercepts of -3 and 3. It does not include -3 and 3 because those would be 0, and that's not, 0 is not neither positive nor negative. Now, you'll notice here neither positive or negative, that's -3 and 3. So please remember that. So again, the intervals above are positive, below are negative, and neither are the actual x-intercepts. Okay, go ahead and punch that. All right, now you're going to try it for what intervals? 2x plus 10 positive. So you would take, and I will go through one of them. So you take and get on your graphing calculator and put in 2x plus 10. Press your graph. All right, here we go. I have a graph, oops. I have a graph here. My intercept is at negative 5. And my y goes up to, see, x is 0, y is 10. So up here is where it crosses the y-axis. So my graph is a straight line. So again, it's positive above, so it's positive up here, it's negative down here, and that -5, it's neither positive or negative. So here we have from -5 to infinity, and over here we have -infinity to -5. So how would you write that? Again, writing in, we're going to go ahead and write it in interval notation. So you would copy off of your notes exactly what you have here. So it's positive at -5, positive infinity. Was that basic? Come back over here and put positive.
You said
No,
negative.
over here. Okay, put positive.
Oh.
No, the word. And then put a colon. All right, then come down, and then it's, put a comma here, space, and then put, oh, hold it, you don't need to do that, it's only that one. Sorry. And come down here and press and put negative, colon, -infinity to -5. All right, and then neither, you can put neither, N-E-I-T-H-E-R, -5 at -50. All right, then we're going to come and check our answer. Now, if they've got it in, oh, the function is, they're only asking us for positive. Oh, we didn't read the question. How many times do we do that and we forget and we don't read the question? We only needed the positive one. So, but this is good practice. So the function is positive over -5 to infinity. So we've got that. But we have all three. That's good. That's actually good for, now, let's come down here. Leave this alone. Let's come down here. Just put a point or something down here in this box. Put a period or whatever. Okay, hit the check answer. Now you notice the function is negative over negative infinity to negative 5. So this right here should have gone down here. So why don't you click out of here. See if you can cut and paste this down to here.
Nope.
No? Okay.
Nope.
So don't worry about it. You can just go ahead and redo this here. Not an issue. And then, okay, that's okay. Don't worry about it. Just make sure that it's correct in your notebooks. All right, next.
And one thing I just noticed, if you hit check the answer, you cannot fix anything in those boxes.
Okay. Okay, for what values of x is g of x equal 2 minus the absolute value of x increasing? What they're talking about increasing is that if I have a graph here, and it says 2 minus the absolute value of x, so I come over to my handy dandy calculator, and I put in 2 minus the absolute value of x, and then I get a graph, and then what I'm going to do is graph this. Now, why is it upside down? Because if I were to write this correctly, it would actually be negative the absolute value of x plus 2. This negative makes it flip over and go upside down. So here and here, this is negative 2 and this is 2. Now, it says when is it increasing? Well, it's increasing when it goes up. So it's increasing from negative infinity to, and this is 2 here, to 2. So go ahead and hit the solution here.
Second part of the question.
And then what value is it decreasing? Go ahead and hit the solution here. And then it decreases going from I'm sorry, this is a 0. And then it's on here, it's 0 to positive infinity, if I'm not mistaken. All right, so increasing.
Yay.
Oh, we got it right. Cool. Okay, decreasing. Oh, I got it right again. How wonderful. And then maximum and minimum. Okay, so it does not have a minimum. This is the maximum. A minimum would mean if it went this way, this would be your minimum value, where it turns from going down and then coming back up. The maximum is where it turns going up, where it turns to go back down. Okay, next. All right, so I'm going to let you guys do this one. We're going to show you the answers though, but I would like you to stop the tape for a minute. I want you to try this problem with your calculator and then check your put your answer in here and check it. Now this one says for what values of x is each function increasing, for the values of x it is decreasing. So we have x squared minus 4x. X squared minus 4x looks like,
Are you going to wait for a second for them to actually work it?
all right, x squared minus 4x is a parabola. If you have your graphing calculator, you'll know that the graph looks like something like that. And it comes down here to 2, negative 4. So this part right here is at 2, negative 4, if I'm not believing. Now, what you can do is you can go to your table, which is second graph, and if you go down to 2, If you go down to 1, it's -3, 2, 2, -4, and then at 3 it goes back up. So 2, -4 is the minimum value of that. All right? So it says, for what values of x is it increasing? Well, it's increasing from here. Sorry, it's increasing from 2 to infinity. So from 2 to infinity is where it's increasing, and it's decreasing from negative infinity to 2. All right? So go ahead and put the, just put a period in there and we'll hit the check answer. Okay, so your answer should look like this. So values of x are increasing as 2 to infinity, and decreasing negative infinity to 2. Right, and then we'll let you do B on your own. All right, next question. Okay, the average rate of change is the slope, but they want the average rate of change over an interval. So it says, what is the average rate of change of when y equals f of x over the interval a, b? So go ahead and hit the solution. All right, so we're looking at this right here. So we're looking at the average rate of change from a, b. So go ahead and put where it starts. Okay, so this is where it starts. This is where it ends. So you would take these two numbers, if they were numbers, and you would put it into slope-intercept form, which is slope form, which is y2 minus y1 over x2 minus x1, or in this case, it would be f of b minus f of a over b minus a. So go ahead and put the total change here. Total change is f of b minus f of a. That's this part right here. Interval level, the length of the interval is b minus a. That would be this part down here. So the average rate of change is going to be f of b minus f of a, which I have over b minus a. This is the same as the slope of the line segment between 2 points, a f of a and b f of b. Remember, this is y. These are y values. Okay, go ahead and hit that. All right, go ahead and hit the solution. Okay, what they want to know is the average rate of change for these. Here, this right here would be at 0. So if I took f of x is equal to 1. So the average rate of change on this one would be 1. So between -2 and 0, it would still be 1. Can you click on that and see what happens? All right, pull it down. So you'll notice, f of x is equal to 1 has the same rate of change, so 0 over every interval. This means that it is a constant function. All right? So the average rate of change is going to be 0. Please click on g of x. Okay, the average rate of change, to find it, change of y over the change of x, it's 1/2. So g of x equals 1/2 x minus 1 has a constant rate of change of 1/2. Remember when we learned this as y equals mx plus b, where m is the slope and b is the y-intercept. Okay, next. Okay, this is a parabola. It's going to be doing something a little bit differently. There is no average rate of change over the entire graph. Now there would be if you just chose 2 points. But over the entire graph, it would not have one. All right, go ahead and push this one. All right, so what you're going to do is you're going to find the average rates of change for the absolute value of x plus 2 over these. Again, the absolute value of x plus 2 is going to look like this. This is going to be a 2. So what you want to do is you want to find the slopes between these two, and those two. All right? I'm going to let you go ahead and find that, but we're going to find out what the answer is, which you should already know. Now, I want you to remember to try to work these out for yourself. Okay, it says the rate of change over the 3 intervals is nonlinear function. So there is no constant rate of change in a function that looks like this. Now, if I just chose 2 points, this one and this one, or this and this, I could find a constant rate of change. All right, next. All right, these are the key features that we learned today. You'll notice here that y equals 1, so it has a slope of 0. If you have something that looks like this, the slope would be undefined. All right, this has a slope. This has a rate of change. This would not, and this would not, unless, of course, you chose 2 specific points. So if I chose a point between here and here, what I would do is draw a straight line, and I would have a slope through there. Otherwise, there is no constant rate of change because it comes down and comes back up, comes down, comes back up. Next. All right. These questions you're going to go ahead and answer. Go ahead and push next. Any question that has a place for you to put an answer in, you will answer. Here, find the domain. Now, here, you may stop. You do not have to do these problems at all. So please don't ask me anymore. What you will get so the first thing that happens is you will get the virtual VIR? Virtual text. That's where you're going to learn how to do the problems. Then the next day you will get XL Math. Or Math Excel, sorry. Math XL. That is where you'll get problems similar to this. You will put them into the computer. Now, this is section 1.1. The next section will be 1.2. On Friday, I will release lesson quiz 1.1 and 1.2. You will have, I believe I have given you the whole weekend. If I haven't, I'll go in and edit that so that you will have the whole weekend, and they will be due Sunday night at like 11:59 or something like that. So you'll have Friday, Saturday, and Sunday to do them. All right? What is graded? What's graded? I will be grading Math Excel and your lesson quizzes. The virtual text is a non-graded assignment, but it is mandatory. The reason it's mandatory is if you do not do this, you will not know how to do that. And if you don't have this done, I will not help you if you come in to do this.
Did you do the turning?
Huh?
Turning.
Yeah, we're doing. Now the next thing you're going to do after you're finished here is you're going to go up here and click Turn In. And they're going to ask you, oh, you're about ready to turn this in. Are you all done? If you're all done, you're going to go ahead and turn that in. And then here you'll see you have completed the assignment. And I will get notification from Pearson realized that you had finished the lesson. If you have any questions, please do not hesitate to come in and either make an arrangement or make an appointment for tutoring, or to email me with a question. Again, please make sure your question is specific. I cannot answer questions like I don't understand anything or how do I do this. Thank you very much and have a nice day.